Lesson 8 is on using formulas in geometry, and a formula, let's define that first. That's a mathematical relationship expressed with symbols, like letters usually are the symbols that we use. And a couple of ways we use formulas in geometry are to find perimeter and area. And we had a figure and we want to find the perimeter. That would be the distance around that figure, basically, or object. It's also the sum of the side lengths of a closed geometric figure. Now, a closed geometric figure as opposed to an open one, this is a closed geometric figure there, and then an open one would be like that, where it's not closed, basically. It doesn't, the sides don't all connect together. So I have some different shapes there. Look at the one on the left there. That's a rectangle, and we know that a rectangle, it has a length and a width. And if we wanted to find the perimeter, everything together, the distance around it, then we would have two lengths to add together and two widths to add together. That's what we could say P for perimeter, that equals, for that rectangle, 2L plus 2W. So there's a formula for finding the perimeter for a rectangle. The next figure there, that's a square. All the sides on a square are the same length, so we'll just say S. And if we knew one side, what its length was, we could figure out the perimeter, because the perimeter would just be 4 times S, or 4S is what we would say. Then next I have an equilateral triangle there. All the sides on an equilateral triangle are the same length too. For that we could say P for perimeter equals 3S. Next is an octagon, and we would say there that P is equal to 8S. That's a regular octagon, it's called, because all the sides are the same length, and we could say S there, label one of the sides S. So let's just say it equaled 2 inches. One of those sides was 2 inches long, and we wanted to know the perimeter around that octagon, that 8-sided shape there. So we would just say P is equal to 8 times 2 is equal to 16. And if the units were inches, we need to write the units down. It's very important to write the units. And if you're doing problems, finding perimeter or area, and you finish working out the problem, and you forget to write your units down, I would consider that half credit on the problem. So the units are very important. Some major mistakes have been made in history because people didn't write the units down, or they wrote the wrong units down. NASA has actually lost satellites out in space because they used the wrong units and sent the satellite off in the wrong direction. Now look at that last triangle there. Let's say this side was 6, this side was 2, and this side was 7. On that one we'd need to know the length of all 3 sides, and then you just add them up. 7 plus 6 is 13, plus another 2 would be 15. That would be the perimeter of that triangle. So the perimeter, that's the distance around an object. We'll talk about circles later in lesson 23. We don't really call it perimeter when we look at distance around those. We call it circumference, something a little bit different, but we're not focusing on circles in this lesson. Well, now let's talk about area. Area is the size of a region bounded by a figure. It's the measure of a surface is another way to think about it. And perimeter, that has units of length. Area basically has units of length times length. Sometimes it's called length squared. And so look at that rectangle on the left, and let's just think about that. If this was, again, the width and this was the length, we would say the area is equal to the length times the width. There's a formula that we could use for any rectangle. And that's the great thing about formulas, is because once you know the formula, then you can apply it to any shape that's similar to that. So probably the difficult thing in math is memorizing these formulas, but once you have them memorized, then it becomes very easy, because you just use the same formula in a huge variety, an infinite variety of shapes of rectangles, and you always know that you'll find the area of any of them by that one formula. Now let's try to understand a little bit more why we call it squared, length squared. Well, look at that rectangle on the left, and let's just say, for example, that it had a width of 2 and a length of 6. We're not going to be concerned about exactly the units, the type, whether it's centimeters, inches, whatever. So let's break it up, though, into individual units. So there would be 2 different sections for the width, and then I need 6 sections for the length. And actually a 2 by 8 measurement works a little bit better for this example here. So just as an example, let's just say this was inches, 2 inches by 8 inches. And so we have it broken up into these sections of 1 inch by 1 inch. So there's these little squares then are 1 inch times 1 inch. They're 1 square inch. And look at how many of them there are. There are 16 of those squares there. So just like if you were laying tiles on a floor or something, covering a surface with something. You can see in this example here, if you had to cover this rectangle with tiles, you would need 16 of them that were a square inch each. And so that's why we would say that the area here is 16. Sometimes it's written out square inches, or you might also see it inches with a little 2 as an exponent there. That is the simplified form of inch times inch. Just like if you had 6 times 6, that's the same thing as 6 squared. Hopefully you know that. You've done enough algebra to know that's how you could write 6 times 6. Here we multiplied the length in inches by the width in inches. So we multiply those units. Inch times inch gives us inches squared. So we write that out as inches squared. And you can see why it's called square inches, because we have these little squares that we're dealing with. 1 square inch each. Now let's say we had a square. Well, we could still do length times width on that, but a square, all the sides are the same length, so we could just say area equals s times s, or s squared. Now, we're not going to concern ourselves with octagons right now and finding the area of them, but we can figure out triangles. Look to the triangle on the right there, and the area of a triangle, that's equal to 1/2 times the base of the triangle times its height, the height that's perpendicular to the base. So if this is a right triangle here, and we'll put a little box there to designate that it is, this would be called the base, and this is the height. Now look at that triangle over to the left again. This would be the base, but what do we use for the height? Well, we'd have to measure this perpendicular distance right here, and we would say that that is the height. So sometimes that's called the altitude on the triangle. So the key to remember on finding the area of a triangle is that we always do the base times the height perpendicular to it. And it doesn't matter what the triangle looks like. I mean, you could have a triangle that looks like this, and we would still do, this is the base right here, and then this distance right here would be the height perpendicular to the base. And amazingly, that gives us the right area for that triangle. Let me just show you how this works in Geometry Sketchpad. I have the triangle here, and you can see the height. If I move this along and drag it along, and I'm changing the shape of that triangle, but the height is staying the same, the base is staying the same. Look at the area over there on the left. It's always 28 square centimeters, no matter what that shape is. But the things that are staying the same are the base and then that perpendicular height to the base. Those are staying the same, so the area stays the same. And so that's how that formula works. The area is equal to half the base of the triangle times the height perpendicular to the base. Let's talk about one more formula, the Pythagorean Theorem. And this is a theorem with a formula. And the theorem says that the sum of the squares of the legs A and B of a right triangle, that's equal to the square of the hypotenuse C. And it's written a squared plus b squared equals c squared. So I have a right triangle drawn there. And let's just think about that. If this side was called A, this side was called B, and normally when you're dealing with the Pythagorean theorem, the hypotenuse, that's the side opposite the right angle, so that one is labeled as C. And A squared plus B squared equals the hypotenuse squared. This is named after the Greek philosopher Pythagoras, and he lived around 500 BC. So he developed this theorem before Euclid. He was a student of the Greek philosopher Thales, and Thales spent a lot of time studying geometry. Now, Pythagoras and his theorem that has been proved in many different ways. You'll prove it in Investigation 8, but there are many different proofs of this theorem. It's a very useful and helpful theorem when applied with the study of right triangles to find distances of sides. It's interesting though, just some history about Pythagoras. He actually formed a religion where they worshipped numbers. It's really kind of strange. He believed, for example, that the number 1 was the generator of numbers, 2 was the first female number, 3 was the first male number, whatever that means. But it's kind of funny actually that this triangle right here actually destroyed their religion. This right triangle with this side equal to 1, this side equal to 1, then side C would equal the square root of 2, which is considered an irrational number. That means it doesn't have a simple ratio. You can't break it down into a ratio of whole numbers. And this completely confused the Pythagoreans, and their religion disbanded because of the square root of 2 of all things. But it just goes to show that men are imperfect. They never completely get everything right. But he did have one thing right, and it's a very useful thing, the Pythagorean Theorem. Now, one more formula that they just kind of threw into this lesson is the conversion of Fahrenheit to Celsius. I like to use this formula here, F equals 1.8 times the Celsius temperature plus 32 degrees. So when Celsius is 0, then the Fahrenheit's 32 degrees, and so on. A little different version, that's where you're trying to find the Celsius temperature given the Fahrenheit. This is what they have in your Saxon textbook, 5/9 times Fahrenheit minus 32. So they use a fraction instead of a decimal. And either one, those are good to memorize. You might want to write down these formulas that we've gone over. Maybe write them down in the front of your book or in your notebook where you're taking notes. Find a separate page for your formulas so you can easily flip to that page when you need them. Think of these formulas as tools, and then that page that you write them all on, that's where your toolbox is. So you know where your toolbox is. You can go to it quickly and find the tools that you need to solve your problems. Let's go ahead and do some practice now. And practice problem A says, find the perimeter of a triangle with congruent side lengths all equal to 4.5 feet. So let's just think about that. We could draw this if we want to, and the Greeks, they used to write everything out, and they didn't really do a lot of drawing and symbols and things like that. They wrote everything out in sentences and paragraphs, so it took them a long time to describe something. But anyway, if we had a triangle that had all congruent sides, they were all 4.5 feet, we would just say 4.5 times 3. That would be our perimeter. And so that would equal 13.5 feet. Don't forget the units on these. That's very important. Put a box around the answer so you can identify its location. Practice problem B, find the perimeter of that rectangle. So we see that one side is 111 meters, the other side is 163. So remember on that we need to say 2 times the length plus 2 times the width. So think about 163, 160 times 2, that'd be 320, and then add 3 times 2 on for 6, 326. And then doubling the width, that's easy. That's just going to be 222 meters. And so we'll get 548 meters for the perimeter there. Practice problem C. Find the perimeter of a 5-sided figure with side lengths all equal to 9 centimeters. So using a formula there, we just say P is equal to 5S. And so we'll just substitute in 9 for S. 5 times 9 is equal to 45. Don't forget the units, centimeters. That would be the perimeter there. 45 centimeters for that 5-sided figure. Practice problem D. Find the area of the rectangle. So let's solve some area problems now. So we have a rectangle and we just need to think, okay, what formula can I use for that? Well, it's just area equals length times width. And so we just substitute in 52 for the length, 12 for the width, and so we'd have 52 times 12. And now on geometry problems like this where you're finding areas and perimeters, I think that's fine to use a calculator on those if you want to. And just to speed things up, the goal here is not necessarily do you know how to do multiplication by hand, writing that out. The goal is can you figure out what formula to use and how to apply it properly. That's deductive reasoning, right? You have a rule, area equals length times width. You're applying that rule in a new situation. That's the essence of deductive reasoning, which is what you learn when you study math. And so we have 52 times 12 is 624. Now we don't just write meters, right? We're finding area, and we multiplied meters times meters, so we need to say meters squared. So that's our answer. It's very important that you write the correct units down. 624 meters squared. Moving on now, let's look at practice problem E. If a triangle has a base of 3 meters and an area of 12 square meters. What is its height? Well, let's just write the formula down. Area for a triangle, that's equal to 1/2 the base times the height, or we can just say b times h over 2. You can write it like that as well. So what do we know here? Well, we know that its base is 3, its area is 12. We need to find its height. So we need to rearrange this problem to solve for height. Let's go ahead and do that first. We need to multiply both sides by 2. And so we'll cross those out on the right side there. And we end up with 2a, actually a capital A there, 2a is equal to bh. Then we need to divide both sides by the base because we're solving for the height. And so that cancels out on the right there. And so we have the height is equal to 2a over b. So just a little bit of geometry there, or algebra there, that we needed to do. Now we just substitute in the information that we have there. 2 times the area is 12, and then over the base of 3. Let's go ahead and simplify where we can here. 12 over 3, that's equal to 4. And so we can just say 2 times 4 is 8. And what would our units be? Well, it's height, so it would just be meters. And just something to consider here, think about what we did there. We had 12 meters squared over 3 meters for the base, so we had meters squared divided by meters. So one of those meters cancels out in the numerator with that 1 in the denominator, and so we end up with meters for units. That's how you get meters for units. Another way to think about it is you had meters times meters. That's also meters squared, right? Over meters. One of those meters cancels. Okay, let's move on to practice problem F. Use the Pythagorean theorem to find A. So you have that triangle there, A, 2, and 3, and the hypotenuse, it's always the longest side, and you can tell it's opposite the right angle, and I don't have that marked there, but we can assume that that angle on the corner there is the right angle. And maybe you notice one thing I've been doing is I write the formula down first. So we have that there, and that's our tool. We can look at that then. We have it on our paper right there. We can look at that and see what we need to do. Here we need to find A. So we know what B is and we know what C is. So we can say A squared, substitute in B, that's 2, so 2 squared would be 4, is equal to C squared, which would be 3 times 3 is 9. And so A squared is equal to 5. Now, let's just move that over. Actually, let's just go ahead and take the square root of both sides because we need to do that to find A. So take the square root there and the square root there. And we would say that A, normally you'd say A is equal to plus or minus the square root of 5, but that doesn't make any sense to have a negative length for a side of a triangle. So we would just say that A equals the square root of 5. And we don't have any units on this particular problem, so we're not concerned with that right now. We just use that Pythagorean theorem to find what A is, what its numerical value equals. Moving on to problem G, use the Pythagorean theorem to find the area of a triangle with a hypotenuse of 5 inches and a side length of 4 inches. Okay, well, we can't see this triangle, but we don't really need to. We need to know what the Pythagorean theorem is, and let's write it down again. And it helps to write these things down. That's why I want you to take notes on the lesson, because when you write things down, it makes it easier to memorize it. It makes it stick in your head a little bit better, and you just learn them better when you see them written down, when you hear them, when you hear me talking about them, and then when you do something too. When you're writing, then you just learn things better that way. So make sure you're doing that, taking good notes. And so we write that Pythagorean theorem out first, and we go ahead and substitute in. We know the hypotenuse is 5 inches, a side length of 4 inches. It doesn't matter which one is 4 inches, A or B. So we'll just solve for B. It really doesn't matter which one we substituted in for. So we'll say 4 squared plus B squared is equal to 5 squared. And then let me move that over to the right. 16 plus B squared equals 25. I need to subtract that 16 from both sides, and I would end up with B squared is equal to 9. Now we need to take the square root of both sides. like we did before, and we see that on the left we end up with b. On the right we have the square root of 9, which hopefully you know that is equal to the whole number 3. So now we need units because we've been talking about them. B is equal to 3 inches there. And so just another thing about that triangle, that's an interesting triangle. It's called a 3, 4, 5 right triangle because if one side is 3, the other side is 4, and it's a right triangle, the hypotenuse is 5. The Egyptians who built the pyramids, they understood about this triangle. They knew about it, but the difference between them, they would use it to build things. The Greeks, they proved why the Pythagorean theorem works. So they were more thoughtful about it, I guess you could say. But really, the best thing is to be able to do both, to be able to build something with this and also to be able to think and understand why the Pythagorean theorem works. And you will be proving this in a later lesson. Well, let's move on now to, let's actually practice problem H down there. Convert 20 degrees Celsius to Fahrenheit. And let's do that one first. Well, again, the whole point of this lesson is using formulas, so the first thing you should think of is what is my formula that I need. There's really only one formula for converting Celsius to Fahrenheit. It's just you'll see it shown in different ways, and I like the one where it's F equals 1.8 Celsius plus 32, and so here we'll substitute in 20 for Celsius, so we'll say 1.8 times 20 plus 32. And one thing I like about this is, well, we can think, well, 1.8 times 10, that's 18. 1.8 times 20, that'd be 36. So I don't have to get a calculator. I can just do that in my head. 36 plus 32, and that equals 68. So we put the units degrees Fahrenheit. So when it's 20 degrees Celsius outside in Fahrenheit, that's 68 degrees, almost 70 degrees Fahrenheit. Now let's convert 212 Fahrenheit to Celsius. I'm going to use the same formula. F equals 1.8 C plus 32. And so we would say 212, we're substituting in there, 212 is equal to 1.8 C plus 32. Now you need to subtract 32 from both sides there. And so 212 minus 32, well, look at the 2's, those would go away, so you'd have 210 minus 30, and that would be 180, is equal to 1.8 C. So divide both sides now by 1.8, and hopefully you can see the similarity there on the left, and you'd get 100. Celsius is 100, so C is equal to 100 degrees C. And maybe you already recognize that from doing science, and in science class you know that 100 degrees Celsius is boiling point. In Fahrenheit, that's 212. So that formula there, F equals 1.8 C plus 32, that's actually called a linear equation. It's an equation of a line, and we'll be studying those starting in lesson 16. Okay, well that's all for lesson 8.